Hello everyone, welcome to our channel Ask Prep. In today's series on 11th grade physics, we will be studying chapter 8, Gravitation, in detail. Let's start the video. Starting with Kepler's laws of planetary motion. Johannes Kepler formulated 3 laws that describe planetary motion. They are as follows. 1. Law of orbits. Each planet revolves around the Sun in an elliptical orbit with the Sun at one of the foci of the ellipse. 2. Law of areas. The speed of a planet varies in such a way that the radius vector drawn from the Sun to the planet sweeps out equal areas in equal times. Next is gravitational field. The space around a body within which its gravitational force of attraction is experienced by other bodies is called the gravitational field. Next is intensity of gravitational field.
The gravitational field intensity of a planet at a point in its gravitational field is defined as the force experienced by unit mass, that is 1 kilogram at that point. Thus, by definition, we can write gravitational field intensity, denoted by capital I, is equal to capital F divided by small m, where F denotes the force of attraction on the body of mass m. But we have F is equal to the product of G, m and m divided by r square. So from the definition, we can write I is equal to the product of G and m divided by r square. Students, if m is the mass of the Earth, in which a body of unit mass is kept at its surface of radius r, that is, r is equal to the capital R, thus I is equal to the product of Gm divided by r square. Let this be equation number 1. But we know that G, or gravity, is equal to the product of Gm divided by r square. Let this be equation number 2. Now from equation 1 and 2, we get I is equal to G. Thus the intensity of gravitational field due to the Earth is approximately equal to the acceleration due to gravity at the surface of the Earth. We can use the gravitational field intensity of a planet at a point to find the weight of a body at that point. That is, weight of a body is equal to mass multiplied by gravitational field intensity. Unit, it is expressed in the unit of Newton per kg.
Next is escape velocity. The minimum velocity required to project a body vertically upward from the surface of the Earth so that it escapes the gravitational field of the Earth is called escape velocity. Orbital velocity. The orbital velocity of a satellite is the minimum velocity required to place the satellite into a given orbit around the Earth. See the image. Thank you for watching. We will be dropping notes in the description of this video. If you found this video helpful, kindly like, subscribe, and share. See you in the next video. All the best for your exam.